Hello everyone. The topic today we are going to talk about is factors influencing the titration jump. In the process of calculating titration curve, when the titration percent is 99.9% in the case of 0.1 mol per liter sodium hydroxide titrating 0.1 mol per liter hydrochloric acid, the solution pH is 4.3, while the pH moves to 9.7 when the titration percent is 100.1%. The value of pH changes 5.4 units, but the titration percent only changes 0.2%. Generally, the pH change associated with the titration percentage change from 99.9% to 100.1% is called titration jump. This definition is also applicable in other titration curves. When 0.1 mol per liter sodium hydroxide is used to titrate acetic acid with the same concentration, the titration jump becomes 7.74 to 9.7. The change of titration percent is still 0.2%, but the pH change is less than 2 units. So what are the factors related to titration jump? For preparing the titration curves, the titration of strong acid or weak acid with strong base are taken as examples. It's obvious that when the titration percent is 99.9%, the solution pH of strong base weak acid system is higher than the pH of strong base strong acid system. This means the initial point of titration jump of a weak acid titration is higher, but the end point is the same. It's quite clear that the titration jump of a weak acid titration is narrower than that of a strong acid. It can be presumed that the titration jump is related to the strength of acid. We already know that the strength of acid or base is represented by the dissociation constant, Ka or Kb. The larger Ka or Kb is, the stronger the acid or base is. Meanwhile, the larger Ka is, the smaller Kb of its conjugate base becomes. And vice versa. Ka or Kb of strong acid or base is 1. Make the titration curves of strong base titrating weak acids with different Ka, showing in this figure. It can be seen that at the same concentration, the stronger the acid is, the smaller the pH is before titration, and the lower the starting point of the titration jump appears. Since the end point of titration jump is the same, it causes the range of the jump to become larger. Otherwise, the weaker the acid is, the smaller the range of the titration jump becomes. Now, we know that the titration jump becomes smaller as the acidity becomes weaker with the same acid concentration. Then, for the same acid with different concentrations, for example, 0.1 mol per liter or 0.01 mol per liter, how is the change of titration jump? Similarly, we plot the titration curves of acid with different concentrations together, as shown in the figure. It can be seen that as the concentration becomes smaller, the pH before titration becomes larger, and the starting point of jump gets higher with a lower end point, exhibiting a smaller titration jump. That is, as the concentration of the acid becomes smaller, the corresponding range of the jump also becomes smaller. In summary, it can be concluded that in the acid-base titration process, the smaller the concentration is, the smaller the titration jump becomes. The titration jump is also related to the strength of the acid or base. That's all for today. Thank you.